You're preparing to register for classes and you want to find the schedule that will give you the least amount of homework. So, like any curious STEM student, you decide to write an algorithm for this optimization problem. Now, the answer is rather easy to find when you're working with 4 to 5 options. However, when the list of classes grows to 10, 100, or even 1,000 courses, you will need a faster way to find an answer. In more recent years, computer scientists have explored a new type of quantum computer called a quantum annealer to solve these optimization problems. And here's how it works. Nature tends to want to be in its lowest energy state, or the ground state. For example, when you pour water on the ground, the water will flow towards areas that minimize its gravitational potential energy. This applies to quantum particles as well. Systems of quantum particles will also want to settle in the ground energy state, and this can be visualized using an energy function. Once we set up the state of the system, the quantum annealer will find the lowest point in the energy function. Quantum annealers make use of a special quantum mechanical property known as quantum tunneling that ensures the lowest state the system eventually settles in is the best possible answer out of all the potential energy states. Now, the driving question for using quantum annealers is this. How can we find the physical system whose ground energy state is the solution to a problem? Mathematically, this physical state can be described using a Hamiltonian function, the simplest model for which is known as the quadratic unconstrained binary optimization function, or QUBO. We want to take the variables in QUBO and minimize their sum or energy of the function. Now this is a little bit confusing, so let's take a step back and construct a QUBO for our scheduling problem. Let's say you have 3 classes and none of them overlap. Now each of them assigns a certain number of hours of homework per week, and you want to select 2 of these 3 classes for your schedule. When creating the QUBO for any problem, we tackle it in 2 parts, the objective and the constraints. Now our objective is that we want to minimize the amount of time we spend on homework. So, let's assign variable names x, y, and z to each one of these classes, where x, y, and z can have values of either 1 or 0. So when a class has a value of 1, we want to include the class in our final schedule. When writing our function, we pair each class with the number of hours of homework, or the weight it will have. So if my final schedule includes only classes x and y, then I will spend a total of 20 hours on homework a week. This is the first part of the function we want to minimize. Now let's talk about our constraints. We can only have 2 classes. To make sure this is possible, we create a quadratic function where the minimum exists when the sum of x, y, and z is equal to 2. So, after combining our objective and constraints function, introducing some QUBO-based mathematics, our final function looks like this and is ready for solving. Quantum annealing has applications to all kinds of optimization problems, and this is just a jumping off point. Thank you very much.